Hello guys, today I show you how you can use the Cel Shader 2.0. I've just created a new map and let's get started. First we should place the post-process volume into our scene. In the post-process volume settings we should disable the exposure by setting these two values to 1. In the misc settings, set the expand gamut and tone curvature amount to 0. And finally, in the post-process volume settings, set it to infinite. Now, navigate to the mesh folder and place the mermaid into our scene. Now go to the materials folder, Cel Shader, and create a new material instance from the opaque one. Apply this newly created material instance to the mesh. We are going through all the parameters here, but first we do the easy stuff. In the base color, you can set the base color of your mesh. You can increase or decrease your band number, set your offset. You can change the softness of your bands, set your position, fall off, and contrast. Here in the color settings, you can set the light color and the shadow color of your material. These two values are multiplied with the base color. For the light color and shadow color, you can use your actual directional light and skylight color. In order to do that, you have to navigate to the blueprint folder, lights, and drag and drop the BP directional skylight shadow manager into the scene. After you select it, select your lights, go back to our material, and you have to disable these two checkboxes. When you see a boolean like this with a question, if the checkbox is enabled, we are going to use the first statement. If the checkbox is disabled, we're using the second statement. So here, light color from color parameter or directional light color. This is the color parameter. We want to use the directional light color and the skylight color. So I have to disable these. As you can see, the mesh became much brighter. That's because our directional light intensity is set to 6. If I decrease it to 1, nothing changes. It changes at runtime. As you can see, the levels are adjusted, but not in the editor. In order to see the change in the editor, you have to select the manager and refresh light values in the editor. You have to click this checkbox. The shadow part is light because our skylight is white and the intensity is 1. With the sun intensity multiplier and the skylight intensity multiplier, you can change the intensity scale of your skylight, and the fill color you can blend between the skylight's actual color and this shadow color. So let's say I set the skylight color to red, refresh the values in the editor, go back to our material, and if I increase the skylight color fill, then it becomes truly red, and if I decrease it, it blends back to the shadow color. What if you don't want to decrease the directional light intensity? So let's just set back to 6. Then you can use the intensity multiplier this way. The light color never exceeds 1 and became a gradient like this. And if you change the intensity again, the material changes as well. You can also use the atmospheric sky. You have to enable it. And now the material reacts with the default atmospheric sky. I'm going to revert back this directional light and skylight color changes. And now I'm going to talk about the different cell band generations. So you can see cell shader banding is procedural or curvature. Right now we are procedural, which is this. The second is banding is procedural or transition. What is transition? So basically you can use 3 colors and your cell shader only have 3 banding. Here you can change the offset, but you can also increase the transition width. With these 2 parameters you can blend between the transition, from shadow to transition and transition to light. The other main type of generation is curvature. So we are enable curvature by disabling this checkbox. Curvature means the cell shader bands comes from a curve. You can open up this curve and change the values here. And you can set your blending as you like. If you enable the use base color texture, you can use a base color. As you can see, the face and the hair is messed up. That's because they are using a different material index. So let's fix that. Create a new material instance. Open them up and set the parent to the tutorial one. This way, any changes made in the tutorial material instance will automatically apply to these 2. We only have to set a different texture. After you've done this, apply these new materials to the mesh. If you open up the tutorial material again and change the band numbers, on the face and on the hair, the change will automatically apply. Let's talk about the cel shade booleans. When use sun only is enabled, when the sun goes below the horizon, still actively affects the material. Add a new directional light into your scene. This will be our moon. Select your secondary directional light set the atmosphere sunlight index to 1. This way the engine knows this light is a moonlight. Also, in order to this error message to go away, we have to set the forward shading priority to 1. Now let's get back to our material and disable this parameter in order to use sun and moon. And when our sunlight goes below the horizon, the moonlight takes over the cel shading. With these two transition parameters, you can set when the transition happens. 0 means the horizon, so the transition starts between 0.05, which is, let's say it's here, and it ends when it goes here. If you set it to a higher number, the sun and the moon transition will happen in a much slower pace. With this, use day and night color transition. If you enable it, you can set different cel shade bendings at night. So at night time, our light color will be yellow and our shadow color will be red, but at night time, our light color will be blue and violet. We can use a light map in our shader, but what exactly is a light map? Navigate to the texture mermaid folder here and open this texture up. This light map in the red channel contains a metallic mask, the green channel is a shadow mask, the blue channel is a specular map, and the alpha is an ID map. So in our shader, enable our light map. And enable the shadow map. The shadow map helps the shader define the shadowy area of the mesh. Like in the texture, shadow is black on the underskirt part of the body. So it's always being shadow, no matter of the light direction. As you can see, the face and the hair is messed up. That's because the face and the hair uses a different light map. So let's get back to our tutorial material and enable the color ID map. Here in the colors, enable this parameter. So let's go over how the ID map works. If you open up the texture and navigate to the alpha channel, you can see black, white, gray, a grayish color. So what does it mean? And the value of the alpha channel is 0, black. This means this is ID 1. white, which is 1, going to use this part. This way you can have different cel band colors on the skin and the body and the clothes. Let's say I want to use all the different color options. Now if I go back to my color parameters, I can set different color. The mermaid model uses curvature cel shade band generation. So let's enable it. And as you can see, I have different curves for the different IDs. The skin uses this skin tone, the body uses this greenish one, and the skirt a blue one. You can open up these curves and change the color as shown before. In order to add more option here, you can open up the mermaid color curves atlas found in the texture curvature. Increase the texture height by the number of new curves you want to add. Add a new curve to it and select a new curve, like this base cel shade curve 02. And now for the skin part, I can use this newly added curve. All is left is the emissive option. If I set it to 1, it removes all the shadows. You can mask this parameter with base colors alpha texture, but the body texture doesn't have an alpha channel. The face has an alpha texture, so let's use it. This alpha texture masks out the eyes and the inner part of the mouth. This way, the eyes and the inner part of the mouth never receives any shadows. So let's continue our journey with the metallic. If you enable it, this will apply metallic matte cap to the mesh. You can set the colors here any way you like it. You can even set different color parameters for each ID. So let's say I want the skin to be red metallic. Now I only change the skin. In the options, you can have the position file of contrast, just as you had with the cel shade bands. You can increase the intensity and the matte cap opacity. This will blend between the matte cap texture and the base color texture. You can have an option to use a curvature matcap, this will react to the light as well. And now that we are using metallic, in the light map option, there is this thing appeared, use metallic map. Yes, I want that. Now if I go back to my metallic map, the metallic part only affects, so only the metal parts will receive this metallic matcap texture. Now we continue with the specular. You can set the color, the position, you can set the size, the hardness, and your contrast. Set the intensity. You can use the base color as a specular light color. You can even set different IDs. Now if we scroll back, use specular map option appeared. Let's enable it. And since we have a specular map in our light maps blue channel, here it is. Now the specular intensity will be masked by this map. You can set your position, set your intensity, your fall off, and in the specular map you can see the specular only affects this body part, the metallic parts, and these lights on the fin. Our next stop will be the Rimlight. You can have the same color parameters as before. Change the position, fall of contrast, and intensity. You can also have a shadow mask. This means the Rimlight won't appear on the backside of the mesh. You can use this threshold to fine-tune it. You can also enable that the Rimlight will be masked with the metallic map, so the Rimlight will only appear on the metallic part with this parameter. And the Rimlight type is add or multiply add. This means if it's enabled, it just added to the base color texture. If it's multiply add, then this color is multiplied with the base color texture and added on top of that. Choose whichever option you like. You can have the same option in the specular as well. If you don't like the metallic matcap or the metallic curvature, you can also have a cube map. This will add a metallic shine to your mesh. Same parameters as before. Next up, we have an inline option. You can have this outline-ish effect, but it's not actually an outline. Change the colors and the same parameters as before. With the pattern option, you can have a comic book effect on your mesh. Change the texture to get a different effect. Now this effect is screen space, but if you want to use it in the UV space, you have to enable this parameter. As you can see, these lines were straight before and remained straight, but in UV space they conform to your UVs. Let's check out the hair specular on the actual hair material. So open up your hair. Here you can use this hair offset to offset the specular, set the tiling, the fall off, the width, and the distortion. This mask specular bidirectional light parameter masks out the hair specular on the shadowy parts. But now I can have the hair specular on the shadows as well. Now let's get back to our tutorial material, and we are going to check out the normal map. The mermaid have a normal map, but only in the fish body parts. If I increase the intensity, I can start seeing the effect. You can choose between two normal blending type 1 or 2. 2 is more suiting to our case, so I switch to 2. You can also have a detail normal map. Set the tiling of it and the intensity. Next, we are going to check out the shadows, but first let's save our map. If I enable the shadows, here is a question right away: simple or advanced shadow? Simple shadows are only working on player characters. So navigate to the maps and open up the Mermaid Demo 02. Here I have a player character. You can find it here. And this character uses this mesh with these materials, and in these materials the simple shadow is enabled. In order to use the simple shadow in our scene, select your BP Directional Skylight Manager, scroll down and enable Simple Shadow. What it does, it draws a line to your mesh, to the sun, and when this line gets intersected with any object, the Cel Shade shadows are disabled. It's easy as that, but keep in mind this simple shadow only works on player characters. You can increase or decrease the debug line, or choose not to show the debug line at all. Now let's get back to our tutorial map and set up the advanced shadow. So here I want to use the advanced shadow, so I disable this parameter. In the BP directional skylight shadow manager, I have to enable the advanced shadow by clicking this shadow 1. And as you can see, this cube, what I just added, casting shadow to the mesh. This only works at runtime, so if I move the mesh now, the shadows are remains in the editor, but if I refresh the values in the editor, the shadows go away. Now let's check out these advanced shadow parameters. I bring back my cube and hit simulate. Here I can increase or decrease the shadow opacity. Set the self-shadow file of the shadow bias. As you can see, the lines are a little jagged. I can increase the bias to get rid of it. But it won't get rid of all of the jankiness, so I have to enable blur shadows. Here are the blur parameters. If you increase these numbers, the radial steps, the instructions of the shader will increase as well, so be careful with these. And the main problem is the shadows will disappear at a certain distance, and this distance is set by here. I can have up to 4 shadow maps. Think of it as it 4 cascades. And I can enable these newly added shadow maps in the shader as well. And as you can see, the shadow 1 and shadow 2 uses blur effects, but shadow 3 or 4 are not using it. It saves performance. You blend between these shadow maps at these distances. The way it works, the camera renders a depth texture, and we calculate the shadows from that. So if you want to increase the performance, navigate to the texture RT folders and decrease the shadow textures sizes. You can see the load 0 uses a 2K texture, but the load 3 texture uses a much smaller map. So you can save performance by not blurring the shadow maps as much and not blurring the shadow maps at greater distances at all. If you are not using the shadows, please disable these parameters, because if they are enabled, they are constantly writing shadow information into these textures. Now let's set up the point light system. Navigate to the blueprint folder, lights, and drag and drop point light manager into the scene. Here, enable use point lights and also enable debug. If you have moving point lights in your scene, then enable point lights are updated real time. Otherwise, you should left it unchecked. Now navigate back to our shader and enable use point lights. Add a point light into the scene. The point lights are only affecting the mesh at runtime, so we should hit simulate. But first, make the point light movable. Here in the option there is a boolean, point light is cel shade, yes. Then you have cel bendings for the point light. If the point light is not cel shade, then it will apply the point light's color to your mesh. If the point light distortion is set to 1, then the point light follow the curves of your mesh vertex normals. If it's set to 0, then you can have this translucent looking effect. But as you can see, the mesh still received cel shade data from the directional light and not from the point light. For point lights only, you can have an option to this point light overwrite the directional sun vector. So let's do that. Now the cel shade is depending on the point light vector, not the sunlight. If you enable the point light color for overridden vector, it actually changes the base cel shader light color to the point light color. And if you want this color to be applied on the shadowy part, you have to enable this boolean as well. You can have the same option for the spotlights, except the override directional light vector. Now let's navigate back to our mermaid demo. Here select the point and spotlight manager and enable the debugs. It's also enable the spotlights. In the material, the spotlights are enabled just like the point lights. And here in the debug, you can see the 4 closest point and spotlights to you. Because if you are open up the shader, you can have up to 4 point lights per mesh and 4 spotlights as well. This doesn't mean you can only have 4 spot or point lights in your scene. This means only the 4 closest to the character will be affected by the point lights. Now let's set up the face shadow. I disable the point lights because we don't need it anymore. So open up the face material and enable the face shadow on the face. This is how it looks without it. In order to use face shadow, you need the face shadow texture, which is unique to this character. In the texture mermaid face shadow slices, you can see a set of textures. You can export these textures by right-clicking Asset Action, Export, and export the mesh as well into a 3D software, and check on the face UV where I draw these lines. You need these custom shadow drawings for your own character, and then you have to blend these shadow maps together to assign distance field map. For this, I made a tool available on my ArtStation marketplace for free. You can download it. It uses a Substance Player file. Substance Player is free. And now I show how you can blend these textures together into a sign distance field texture, so you can use it as a face shadow map. After you downloaded and extracted the zip file and also installed Substance Player, double click on the face shadow blend. Set your output size to 2K, set the view to fit, and now you should apply some inputs. Here, in the first input tab, you have to select the number of pictures you have. I have 11 pictures. If you have like 6 or 8 or whatever, then you have to set it to 8. And also decrease the opacity up to 8. In the SDF tab, which means sign distance field, you can increase or decrease your blur intensity. In the output, you can apply a blur to the whole texture. If you change the tab to test output, you can test how it is going to look like in the cel shader. And now you can export this texture as a bitmap. Now let's check out the outlines. Navigate to the material outline folder and create a new material instance from the opaque outline material. You can apply the outline material as an overlay material to the mesh. Open up the instance and set the outline thickness to the desired size. Here in the outline material you have a few options. For example, use a base color texture, and when the outline is white, it applies the base color texture as an outline. Can still change the color as well. You can use 2 colors for the outline, so let's enable it. Color 1 is white, color 2 is like this magenta, And with the gradient position, fall off and contrast, you can increase or decrease the blend distance between the two colors. If two color is not enough, you can also use a curve. And you can have as many colors as you like. You can also have variable thickness. Let's increase our base thickness to something really big, and we can change this variable thickness position and fall off. There is an animation option for the outline, where you can set up some vertex animation. The only problem with this method, the overlay material applies this material to all material indexes of the mesh. And what if I don't want the eyes and the face area to receive outlines? In the mesh, I have a painted vertex color mask on the eyes and the face area. And with this use vertex color mask parameter, you can simply mask out the outline generation on the eyes and the face. The other problem with this method, it uses the vertex normals, and if you have a split vertex normal, the result can be very weird. Navigate to the meshes, promo meshes, and place the cube into the scene and apply this overlay outline material to it. So as you can see, the outline is split where the vertex is split. In order to fix this, you have to use my old outline blueprint method, which means just get rid of this outline and add a new component to this static mesh. BP outline SM component. SM means static mesh. There is also a skeletal mesh one. After you selected the component, you can set an outline material to it. So let's just set the material which we just created to it, and you can have a custom outline mesh. So in the mesh folder, I have a custom outline mesh for the cube. So let's just add it, and nothing happens. That's because it only works at runtime. But now the outline splitting is fixed. And that's because this outline mesh have smoothed vertex normals, and this one have splitted vertex normals. Thank you guys for watching, and I hope I helped understanding the shader. And if you have any question, you can reach me on Discord, link in the description. Thanks, bye.